Welcome back to another video on object-oriented programming using C Sharp. Today we will be diving deep into very first solid principle, the single responsibility principle or SRP in short. In object-oriented programming, this principle lays the groundwork for clean, maintainable and scalable software design. And we are not stopping just with the theory. We will walk through a practical example to show exactly how applying SRP adds real value to your code base. Let's get started. The single responsibility principle states a class should have only one reason to change. This simply means that every class should have only one job or responsibility. If a class is doing more than one thing, it's violating this principle. So it should have just one reason to change in its entire lifetime. Let's understand this better with a real world analogy. Think of a restaurant waiter. The waiter's responsibility is to take orders and serve food. Now imagine if the same waiter had to also cook food, clean tables, handle billing, and also fix plumbing. That would be a chaos, right? Likewise, in code, one class doing too much becomes messy, hard to test, and a nightmare to maintain. So, this is exactly the problem that single responsibility principle fixes. Now, let's look at a code example that violates the single responsibility principle. And then let's look at a code that applies single responsibility principle and solves the problem. Let's get started. Let's look at this seemingly functional order processor class because under the hood it has few issues. This class is doing way too much. According to single responsibility principle, a class should have only one reason to change. But here we have at least four. Now let's look at them. It has order validation logic, database operations. It also has email notification logic, which should have been in a different class. It also has logging logic. This is like asking your waiter to take your order, cook your meal, email you the receipt, and then update the restaurant database all at the same time. Imagine the chaos in the kitchen. Now let's apply single responsibility principle to this process order class and let's see how it turns out. Originally, our order processor did validation inline. Now we have extracted all the validation logic into its own class called as order validator. Look at it, it only has one job. It checks if the order total amount is greater than 0. If more rules come later for this validation, we add methods or new checks just inside the order validator class, not directly in the order processor. So we have extracted the validation logic out into its own class called as order validator. So point to keep in mind that we should not be overdoing single responsibility principle. I'm not telling for each validation rule we will be creating a different class. We look at it from an abstracted perspective and we know that validation on the whole is one responsibility. So we have created a class called as order validator. Even if there is a new validation that comes in future, it will come into the same class. We have also used an interface just to keep it modular. Now let's look at the next responsibility. In our old code, we opened SQL connection and executed insert command right inside order processor to persist the data. Now we have extracted that data saving logic into its own class called as order repository. And yes, we have made use of interface here to keep it modular. Now the next responsibility our old code was doing all in one place was sending email. Now we have extracted it into a email service class. Again, we are making use of interface. Now all this class does is to build a confirmation message and send it via SMTP. So we have extracted sending email logic into a separate class called as email service. The last responsibility our previous code was handling all in one place was the logic for logging. We have extracted that out into a separate class called as file logger. which now encapsulates exactly one thing, that is appending text to a log file, a flat file. So we have used an interface just to accommodate any new implementation for logging. For example, if we decide to write to a different API instead of logging to a flat file, we can give a new implementation using the interface. So the main point is that we have extracted out the logging logic, which was there in the previous class, all at one place into a separate class called as file logger. Our original order processor class was a monolith. It did validation, database, email, and logging all in one place. So that was 4 reasons to change. Now its only job is to coordinate. We have used constructor injection to inject our 4 dependencies. Now we call them dependencies because we have extracted them into their own class. And we should also note that we are not creating objects of those extracted implementations. We are using interface. So we are injecting interface. Just in case if there is any new implementation, we will be able to swap the implementation just in the injection place by not even touching the order processor class. So that's one more advantage. Now let's see how we are consuming it in our new order processor class after applying single responsibility principle. So we have dependencies injected in the form of interfaces, wherein we had actual code inline. Now we don't have any more actual code inline. Rather, we are using the interface, the reference of the interface to call their respective methods. The code exactly does the same thing that it was doing before. All right. Now that we have seen how to apply single responsibility principle, let's break down and also understand why is it so powerful. Easier to understand, when each class has just one job, it becomes smaller and more focused. Think about reading a class that only validates an order. No SQL, no email, no logging, just pure validation. You instantly get what it does. That's what we mean by saying easier to understand. Easier to maintain. Now imagine a bug pops up in the validation logic. Since your validation is in its own class, you can just jump straight in and fix the logic. And you don't have to worry about accidentally breaking the database or the email system. That's what easier to maintain really means. Changes in one part do not affect unrelated logic. Easier to test. Unit testing really becomes a breeze. You don't need to spin up a real database or mock email just to test your validation logic. Each class can be tested in isolation because you're not carrying around a bunch of extra baggage. That's why it's marked as easier to test. Promotes reusability. Because each class has a single clean responsibility, it's now reusable. Imagine your email sending logic can be reused in a password reset flow. Your logger can be reused in a different domain entirely, and none of them depend on each other in weird ways. So that's why it promotes reusability. Enhances collaboration. Single responsibility principle also makes it easier for multiple developers to work on same code base. Imagine one person can work on logging, another on email, another on some other business logic, and none of them are stepping on anyone else's code. One class, one reason to change. That's the core of single responsibility principle. So whether you're writing, maintaining, or testing code, single responsibility principle gives you focus, clarity, and freedom. It's not just a principle, it's a superpower. Thank you for watching our video. Do subscribe our channel for more such videos, and thank you for your support.